Hello, I'm Zach. Today we are reading of Eloquent JavaScript regular expressions. Because this chapter is pretty long, if we finish it in one video, the video will be way too long and there will be too much thing for you to digest. So I decided to make this chapter into two videos. So let's begin with the first half. Regular expressions are objects that represent patterns in strings. So it helps you to deal with strings. They have their own syntax to express these patterns. They form a small separate language that is part of JavaScript and many other languages and tools. So if you know regular expression, you can use it in different kind of programming languages. Understanding regular expressions will make you a more effective programmer. Okay, so how to create a regular expression? In JavaScript, regular expressions are just objects. So you can use a constructor, the regX, to create a regular expression. Here is an example. We just use the new keyword and the reg constructor to create a new expression with the pattern of ABC. Or you can just use two forward slashes. Like here, we put ABC in the forward slashes pair. Okay, this pattern means just three characters. We are looking for three characters, A and then B and then C. That's it. We are looking for ABC. Okay. So what if you want to put a you want to put a forward slash in your pattern? You can use a BestFlashXscape. Here is an example. You want the forward slash to be in your string, which means you are looking for a string like this. You can put a backslash in front of the forward slash. It will escape the forward slash, make it into a normal character. So you will get this as your pattern. Backslashes that are not part of special character codes, like this one, it's a special character code. We will see more of them. Will be preserved, which means if they doesn't mean anything special, they will be a normal backslash. Like here, we have a backslash in front of T and it doesn't mean anything, so it will just be a normal backslash. So you are looking for a pattern like this one. Okay, special characters like question mark, plus sign must be preceded by a backslash if they are meant to represent the character itself. Okay, here we have 18 plus, and we want the plus to be a normal character, just a plus sign after the word 18. So we have to put a backslash here, otherwise it will be it will has a special meaning. But with a backslash escape, it will become normal plus sign. Okay. The first method of regular expressions is test. Here it's used to test a pattern on some strings. Here is an example. We have this pattern we created before, and then we use the test method of regular expressions, and we test on the string of this one, right? So we are looking for ABC, and there is a ABC in this string, so you gotta choose as the return value. And on this line, we have the same pattern and test it against ABXD. So it won't be able to find ABC in this string, so you got a false return value. If you want to match any characters in a set of characters, you can use the brackets. Here is an example. We put a brackets around 1 to 9. That means anyone in this group matches. We are looking for anyone, any character within this group, which means if you got a 0 in the string, you found it. You got a 2 in your string, it also works. So look at this example. We testing it against in the string in 1992. Of course, we got 4 digits here, so this pattern works because you only need any one of them. Of course, it can be more than one of them, like 2 of them, but at least one of them, right? So a better way to indicate 0 to 9 is using a range. We use dash to indicate a range of characters. Here is an example. The same 0 to 9 in brackets, we can write it as this, just 0-9. That means from 0 to 9. So the order of the range is based on the Unicode number. I mean, you don't need to remember all the Unicode number. You can just Google it when you are not, or the order. They usually make sense, like 0 is before 1 and A is in front of B, you know what I mean? Okay. And here are some of the common character groups. They have a special meaning. For example, backslash with D means any digit character, and backslash with W, low case. Okay, means they are the first 3 are all low case. Okay, backslash with W means an alphanumeric character, or aka word character. And backslash S means any white space characters, means space, tab, new line, and things like that. If you use a capitalized D, you got a opposite, like invert pattern. For example, this one means a character that is not a digit, which is opposite to the lowercase. Okay, and this one is opposite to the lowercase w, and this one is opposite to the lowercase s. Okay, and if it's just a dot, means any character except for new line. Again, just to remind you, they are case sensitive. Okay, here is an example. We create a new regular expression. We need 2 digits, right? This is 1 digit, and this is the second digit, and followed by a dash and 2 more digits, dash, 4 more digits, and then a space. Again, 2 digits, colon, and finally last 2. So we test it against this strings, it will return 2 because it's 2, 2, 4, 2, colon 2, exactly as the pattern, as in the pattern. But when we change the O1 to JAN, it will return false because it doesn't match the pattern, 2-digit, right? Okay, here is another example. We have a bracket, means any one in that group is enough for returning true. So we have digits, right? And these two are considered as one thing. And then we have just a dot, so a period. So we are looking for either a digit or a period. So any period, any digit, or a period character would work for this pattern. That means special characters like the periods lose special meanings in square brackets. Okay, but some of them still keep their special meaning. For example, the carrots, to invert a set of characters. Pay attention, it's a set of characters, not just one characters. So here's an example. We have square brackets, and then we have carrots, and followed by 0 and 1, which means it's looking for anything that's not 0 or 1. Okay, the first string we are testing is this one. It's consists of 0 and 1, so it will not pass the test because we are looking for anything that's not 0 and 1. Okay, and the second example, we have a 2 in it that's not 0 and 1, which means we match pattern. So we got a true. And repeating, if we put a plus sign after something, it means repeat more than once. If you put asterisk after something, it means you allow matching 0 time. Let's take a look at the example. Here we are matching digits more than 1, right, in single quotation mark. And here we have 1, 2, 3, and of course they match because we have 3 digits here. That's more than enough. But in the second line, we have the same pattern, matching just 2 single quotation marks. So you got a false. And then we change plus sign to asterisk, matching the same 3 digits. It works, of course. And it also works for empty string. But if you put ABC into that 2 quotation marks, you will get a false because it's not empty anymore. And question marks means optional, so it allows your the character before it to occur 0 or 1 time. So here is an example. We are matching neighbor with a question mark after the character U, so it will match table with a U or without a U. Okay, they are both true, right? And we also have brackets, which means repeat certain times. If you put 4 in the brackets, it means repeat 4 times, and it can also be a range. This means repeats 2 to 4 times. That means it can be 2 times, 3 times, or 4 times. If the upper edge of the range is empty, that means just without upper limit. So this means repeat more than 5 or more times. Okay, here is an example. It's the same one as before, trying to matching the daytime. So we have 2 digit here, 1 or 2 digit. So the date can be 1 or 2 digit, and then the month can also be 1 or 2 digits, and finally the year is 4 digits, and hour and minutes can also be 1 or 2 digits. Okay, I'm sorry, minute is set to 2 digits, right? So here this one, because it can be 1 or 2, so it matches, and this one also can be 1 or 2, it matches. Perfect. And grouping sub-expressions, we can use parentheses to group sub-expressions. And there is another idea called option. We can put some options after a regular expression. Here is an example. We have an I option here, which means case insensitive. Okay, you put the option after your backslash. Here is an example. We put, this is our pattern, and then we put the I after that, which means we are matching it with case insensitive option on. Okay, we are matching the first part. It's the BOO and plus sign. Plus sign means the O can be 1 or more than 1. And we have a parenthesis here, which means this is a sub-expression, and we have HOO in the parenthesis, and plus sign means O occurs 1 or more than 1 time, right? And this plus right after the sub-expression means the whole sub-expression occurs at least once or more than 1 time. Okay, so when we are matching this string, firstly the B is capitalized, but it doesn't matter because we are matching it, we have the case insensitive option on, so this will still match these parts. So the O can be 1 or more than once, right? So this works. And the second part, the sub-expression, here we have this part, because the O can be 1, can be more than 1, right? Okay, and the whole sub-expression can be more than 1. So this is the second occurrence of the sub-expression, and this is the third, right? So this string matches this pattern. Cool. And the exec method, obviously it's from execute, and the test method returns a Boolean value. The exec method returns null or no match, or the match string object otherwise, and the return object contains an index property shows where in the string the successful match begins. So here is an example. We are matching digits with more than one digit. Okay, so we are running ASIC on this regular expression and against this string, and we have 3 digits in it, so it matches the pattern we have here. If you print the result, you will have this. That's the matched string, right? And if you print out the index of the result, let's do the count. Remember, string starts with 0, so 0, 1, 2, 3. Space also count as one element, right? One index. Okay, so 0, 1, 2, 3, 4, 5, 6, 7, and 8. That's the beginning of the match string, right? And string values have a match method that behaves similarly. Here is an example. This is a string with double quotation mark, and we are using the match method, trying to match the same pattern, and we have the same result. Okay. When regular expression contains sub-expressions grouped with parentheses, the text that match those groups will also show up in the array. The whole match is always the first element. The next element is the part matched by the first group, the one whose opening parenthesis comes first in the expression, then the second group, and so on. Let's take a look at this example. We are matching single quotation mark within it. Within them, we have a sub-expression. Okay, and there is a bracket inside that sub-expression, which is matching not single quotation mark, which means these parts match anything that's not a single quotation mark and can be more than one character, or it can also be just empty, right? It asterisk allows occurring 0 time, right? So we are testing it against this string. So we found a pair of single quotation marks, and that will be, and within it, I mean anything, as long as it's not a single quotation mark matches these parts. So we got this one as our result. And the second element of our returned array is the sub-expression, the match for sub-expression, which will be this part, just without the single quotation marks, right? So we got hello, and this one is hello with single quotation marks. Okay, when a group does not end up being matched at all, for example, when followed by a question mark, its position in the output array will hold undefined. Similarly, when a group is matched multiple times, only the last match ends up in the array. Okay, here is an example. We are matching badly, but the li is in a sub-expression, and the question mark means this part is optional. So when we match it with bad, it returns true because it matches the pattern, because this part is optional, right? But this part doesn't match, which means the sub expression doesn't match. So we have undefined for its place, right? And if we are matching for digits more than 1 digit, right? And we have 3 digits here. Of course, the result, the whole match is this one, but our sub-expression is just 1 digit. So the first one who match our sub-expression is the number 1, and then 2, and then 3, and only the last digit will be kept. So we got 3 at this position, right? Next thing we are going to talk about is the date type. So it's a standard object type for representing dates. You can create a date object with this syntax. So a new keyword and then the constructor, and you pass in year, month, day, and then hour, minutes, seconds, and milliseconds. But the tricky thing is months start at 0. Therefore, December is 11 rather than 12. And days start at 1. So don't forget this. The last 4 arguments, hour, minutes, seconds, and milliseconds, are optional. They will be 0 if you don't pass anything. So here is an example. We create a new date object, and it will be the current daytime. Okay, and if you pass in a particular date, you will get this as the exact day as the result, and the last 4 arguments are not given, so they are all 0, and milliseconds is not shown. And of course, you can also pass in the last 4 arguments, but again, milliseconds is not shown. Another concept about the date type is timestamp. Timestamps are stored as the number of milliseconds since the start of 1970, using negative numbers for times before 1970. It's just a convention called Unix time. So you can use the getTime method on a date object to get the timestamp. Here is an example. We create a new date object and use the getTime method on it. You will get a bunch of numbers, and they are the timestamp, and it will always be different because it's based on millisecond. When you run it, it's a different millisecond, right? You can have 2 same millisecond because time is always passing, right? So except of course, if you pass in a particular daytime and hour, minutes, second, millisecond, you will get the same result. But if you are getting the timestamp of now, they will always different because there isn't 2 same now, right? And you can reverse the timestamp to get the daytime. And if you want to get the timestamp, you can just use the now method on the date constructor. Okay. Some other methods for the datetime, we have get full year, that would be 4 digits, and then get year, 2 digits, get month, get dates, get hours, get minutes, and get seconds. Here is an example. We have a function called find dates. So we are passing in this string into the string argument, and then we have a regular expression here matching 2 digits as a subgroup, sub-expression, 2 more digits, or 1 or 2, I'm sorry, 1 or 2, because it's a range, 1 or 2, 1 or 2, and then 4. Obviously this is the date, and this is month, and this is the year. So we run it against the string that's passed in, so this one, and the whole match will be match 0, right? We save it to match, right? Match 0 will be the whole match. And then the first sub-expression will be at the index of 1, and this is the day. The second sub-expression will be at the index of 2. That would be the month, this one. And finally, the third sub-expression will be at the index of 3. So, but when we create a date object, we pass in year, month, and then date. So the first argument is the last element in the array, and we have to turn it into a number, because the date object, the date constructor takes number, right? And the second one is month. Remember, months start at 0, so you have to minus 1. And finally, we have the date. Therefore, you get a date object as a return. And I'm gonna stop right here, because that's a lot of information, and there will be a lot more, and we will cover it in the next video. Thanks for watching. I will see you soon. Bye.